Okay, so let's define it. What is a file system? A file system stores and organizes data and can be thought of as a type of index for all the data contained on a storage device. These devices can include a hard drive, an optical drive, or even a flash drive. File systems need to keep track of not only the bits that make up the file itself and where they are logically placed on the hard drive, but also information about the file. The most important thing it has to store is the file's name. Without a name, it will be nearly impossible for end users to find the file again. And the file system has to know how to organize files in a hierarchy. This hierarchy is usually called a directory. File systems also store metadata. And we're back to our old friend metadata. As you by now know, metadata means data about data. While metadata may sound like a relatively recent and modern concept, all file systems right from the very beginning had to store at least some metadata along with the file and the file name. One important bit of metadata is the file modification date. Not always necessary for the computer, but again, really important for the end user to know so they can be sure that they're working on the latest version of a file. A bit of metadata that is unimportant to end users but crucial to the computer is the exact physical location or locations of the file on the storage device. Other examples of metadata include attributes, such as hidden or read-only, that the operating system uses to decide how to display the file and who gets to modify or view the file. Multi-user operating systems typically store file permissions as metadata. Before we get into the history of file systems, there is one concept that you need to understand early on, and that is the concept of journaling. Journaling in file systems are a way for the file system to increase fault tolerance. The file system will keep a journal in a log file of all file changes before committing them to disk. This means that in the event of a system crash or unexpected shutdown, there is a record of changes that can be used to recover and restore the file state to just prior to the crash event. This is really handy, and most modern file systems now incorporate journaling. Let's now look at the history of file systems. Originally, computer file systems were simply part of the operating system, without predefined names or predefined structures. One of the first file systems that could be considered to be set apart from the OS and had clear standards was the deck tape system. It was a product of the Digital Equipment Corporation, and they used large magnetic tapes for storage. In 1973, Gary Kildall wrote a very basic operating system called CPM. CPM stood for Control Program for Microcomputers. CPM had a very basic file system, simply called the CPM file system, and it simply stored files in a flat hierarchy with no directories. The file names were limited to 8 characters and had a 3-letter extension to signify the file type appended to the end of the file name. Does that sound familiar? The system had to be very simple, and the file names and extension rule had to exist to ensure compatibility between his home microcomputer and the office mainframe. He soon quit his job, founded a company called Intergalactic Digital Research, and started selling CPM to other companies. His CPM OS only worked on 8-bit hardware, and soon enough, a programmer called Tim Patterson wrote a 16-bit version of CPM that he called Quick and Dirty Operating System, or QDOS. He based QDOS on Microsoft Disk Basic. Microsoft Disk Basic used a file organization method called File Allocation System, or FAT. Bill Gates bought QDOS from Tim Patterson and renamed it to MS-DOS. He then used his new company called Microsoft to sell the new operating system with the new FAT file system to nearly all IBM compatible computer owners. FAT was still a very basic file system with CPM right at its core. It had the same limits then, namely the 8-character file name limit and the 3-character file type extension limit. It was designed to be used on floppy disks. The FAT table was essentially a very basic index that kept track of free space and damaged space. Damaged space were called bad sectors on a floppy drive. It was ideal for floppy drives since floppies at the time could store very little data. So it basically just dumped the data anywhere that was flagged as free and flagged as not damaged. FAT did not support directories or any kind of space optimization. This was fine for floppies, but soon enough, IBM released a 20 megabyte hard drive. And now FAT had to be updated. So Microsoft released MS-DOS 2.0 with directory support. Files could now be nested inside folders. By 1987, FAT was replaced by FAT16. It could support up to 2 gig hard drives. Since it was still based on the file allocation tables, the OS still just stored files any place free space existed and space that was not flagged as damaged. This became an issue with larger and larger storage being available to end users. People were now deleting, copying, and moving files around at such a rate that the hard drive had to work harder and spin more frequently to locate and store files. This meant the OS started to feel sluggish and unresponsive. This issue became known as fragmentation. It would not be until Windows 95 that Microsoft would include an end-user tool to combat this issue directly. However, several other third parties made software available at a cost that allowed end users to defrag their hard drives. By 1995, the 2 gig limit for FAT16 was a real issue, and Microsoft then released FAT32 with Windows 95. Since it was still based on the original CP/M, the 8-character file limit was still a problem. So they included a new system called VFAT. VFAT allowed end users to create long file names, and the file allocation table could still store and read them. VFAT took the long file name, and this could be up to 255 characters, and created a short version of it that fit within the 8.3 format. The remaining letters were stored in a type of phantom library. They were sliced up into 13-letter chunks and stored as phantom directories that was marked in the metadata with their attributes such as volume label, system median, and read-only attributes. FAT16 and FAT32 are widely supported by most operating systems, including Linux and Mac, and they are frequently used on USB and external drives. However, they have a major problem, and that problem is that they can only store file sizes up to 4 gigabit in size. So large files, such as big movies, cannot go onto a FAT16 or FAT32 USB. So Microsoft released exFAT in 2006. exFAT stood for Extensible File Allocation Table. It has now been officially adopted by the SD Card Association for all SDXC cards larger than 32 gigs. exFAT has a very low overhead and is ideally suited for low-powered, low-memory devices. exFAT is thus an ideal file system for external hard drives, flash storage, and other portable media devices that need to be compatible between various operating systems. The 1984 Macintosh shipped with MFS or Macintosh file system. It had a 20 meg limit and could store a maximum of 4,096 files. File names could be 63 characters long. This was fine, since the 84 Mac shipped with only a single floppy drive. It had a very rudimentary directory system, and while it worked okay on floppy drives, it was extremely slow on hard drives. In 1985, Apple replaced MFS with HFS, the hierarchical file system. File names were now limited to 31 characters, and the file, directory, and free space information was stored in a binary storage structure called the B tree. This meant that it was an extremely fast file system. The initial release of HFS could support drives up to 32 gigs, but it was later updated to support up to 2 terabyte hard drives. MFS and HFS introduced an innovative way of handling files called forks. Instead of storing metadata in a separate place, HFS made each file into two files, the file itself or the data fork, and an invisible resource fork that contained structural data, including information about the file, such as its icon. Resource forks were used for a lot more than just metadata, though. For example, they held details of the application's user interface and the executable code in pre-Power Mac PCs. Like prongs on a fork, the data and resource traveled around together all the time, as long as they travel between Macintoshes. It did not work on other operating systems. HFS was the first instance in history where a file system was designed specifically to adapt to the needs of the then new graphical user interface. Why else would it be storing information about icons? The whole philosophy of the Macintosh GUI design was to hide unimportant details from the end user. This human-centric design was intended to help people focus more on their work than having to focus on technical details, such as the file system. File paths and non-critical information was hidden to the end user by default. HFS had some other technical limitations though. All the records of files and directories were stored in a single location called the catalog file, and only one program could access this file at a time. There were some benefits to this, like very fast file searches, but multitasking was an issue. So the first Macs did not even have multitasking. But Apple eventually patched multitasking in, but now it caused a problem with certain programs slowing down the system as they waited for other files to read the catalog file. In 1998, Apple released HFS Plus to improve on HFS. HFS Plus now also shipped with a journaling file system. HFS Plus is an improved version of HFS, supporting much larger files and using Unicode for naming files and items. HFS Plus permits file names up to 255 characters in length. In 2016, Apple announced a new file system at the Apple Developers Conference. They called it the Apple File System, or APFS, and it was officially released in 2017. APFS is designed to take advantage of solid-state and flash storage, with a very strong focus on encryption and security. It is specifically designed for 64-bit operating systems, and today it is the default OS file system type for Mac OS, iPad OS, iOS, TV OS, and even Watch OS. And this brings us to Unix and Linux file systems. UFS, or the Unix file system, was created by the researchers at Berkeley University of California. It was an improvement over the original Unix file system, and it became the standard at the time. It is also sometimes called the Berkeley Fast File System. UFS, or BFFS, is a case-sensitive file system. This means that spelling becomes very important when dealing with Linux file systems. This could lead to compatibility issues when moving services like web servers between Microsoft and Linux servers. Many Unix vendors implemented their own versions of UFS, often making them completely incompatible with each other. Sun added journaling to each version in Solaris 7, and Next created its own version of UFS for the Next Step operating system that would eventually evolve into macOS X. In 1992, EXT, or Extended File System, was released specifically for the Linux kernel. By 1993, EXT2, or the second generation Extended File System, was released for Linux. It is a non-journaling file system, but it did support basic compression and decompression. It is still considered a good file system today for small storage drives or for small solid-state drives, since the lack of journaling means less frequent disk access is needed. In 1998, ext3 was released for Linux. It added journaling to ext2 as well as support for larger directories and files. ext4 was released in 2008. Today, this is the default file system for nearly all Linux systems. It improved ext3 in numerous ways, but it is fully backwards compatible with ext3 and ext2. However, it has little to no direct support on Windows or Mac OS. Here we can see a brief overview of the layout of a typical Linux file system. You have root right at the top, and then nested below it, the various directories. These are the most important ones in a Linux system. Bin, for example, contains all the essential user command binaries like bash and chmod. You will learn a lot more about this in the Linux course. Then ext has all the configuration files for the system like cron tab, cups, fonts, hosts. sbin contains the essential system binaries like fdisk to format a disk, or makefs to make file systems, or ifconfig to set up the IP and networking on a Linux server, and then the user or USR directory contains the most often used user commands and the user libraries and even the locally installed software for that user. However, the user home directory is not contained here. Then we get var, which is all the variable data files, where application cache are stored, log files are kept, and optionally installed packages are kept. And then on the far right, we have dev, home, lib, mount, opt, proc, and root. Now, home is where the user home directories will be, dev is for the device files, lib is for the libraries and kernel modules, to extend the kernel to support more hardware. Mounting is easy, that's just to mount new file systems or folders when you install them, or network drives, and opt for optical software. And then, of course, root. Again, this root is for the home directory for the root user. You will learn a lot more about this in the next course after MST. And we're back with Microsoft, and they have yet another file system called NTFS, or New Technology File System. Microsoft realized early on that they needed a more robust and modern file system than FAT if they wanted to dominate the business world with their operating systems. In 1993, they released the New Technology File System, or NTFS, together with their then brand new Windows NT 3.1 operating system. NTFS was designed from the ground up and implemented a host of ideas that included Unicode to support any language for file names, 64-bit support, volume size up to 16 exabyte support. NTFS also used B+ trees. It's an updated version of B trees that Apple used with HFS. It supported journaling, it supports compression and decompression, it supports access control list security. This was added in Windows NT 3.5, and extensive metadata support. It had so many advanced features built into it that it took the Windows operating system several years to implement all of them. NTFS version 3 added disk quotas and encryption. NTFS is built on proprietary technology owned by Microsoft, and as such, official support is limited to just Windows operating systems. This means that officially it doesn't work on Linux or Mac OS, but there are ways to make it work, and there are always software vendors willing to sell compatibility. The term volume partition are often used in connection with file systems, but what exactly is a volume or a partition? Before you can use a hard disk drive, a flash drive, or any kind of storage, it needs a file system. And before you can format that hard drive for a specific file system, you first need to partition it. So to define it, a partition is a persistent division of a physical hard drive into logical segments. Each partition appears to the end user like a separate hard drive. Volumes are the terminology used by post-Windows 2000 machines for partitions. Partitioning a hard drive means each segment behaves like a separate disk. This is ideal for dual booting, for example. A single hard disk drive can hold multiple partitions or volumes, and thus also multiple file systems. Here you can see we are partitioning a hard drive during the installation of Windows. Here we are partitioning a hard drive from within Windows using the disk management tool. Here we are partitioning a hard drive when we're installing Linux. And here are we within Linux using gparted to partition various drives. And we can even do it from the command line.